you may have to recognize various shapes in graphs, and some of these things, if you burn them into your brain, you should recognize them straight away. So first of all, this graph here is showing positive voltage and negative voltage. Basically, having positive voltage and negative voltage is talking about sticking the batteries the wrong way around, or changing the direction of the batteries, or changing the wires around in a circuit. You know, you've got a positive terminal and a negative terminal. And the plus current, plus I, and the minus I is actually telling us the directions in which the current's going. Now, what you should find out when you investigate any conductor, we normally do it with resistors, that as you increase the voltage, the current increases. And that straight line is actually showing you increase the voltage, the current increases in a predictable fashion. And that is the basis of Ohm's law. That is actually, that graph there is demonstrating Ohm's law, and it is true for a conductor at a constant temperature. Now, it's very difficult to get any conductor or any device to stay the same temperature. What we get more often is this. This is showing the same thing. You know, as you increase the voltage, the current increases. But if you notice, there's a curve to it, and this characteristic curve that you see in voltage and current tells us that it is a filament lamp, that it is something that is getting progressively hotter. And what it's showing there, that is, as you increase the voltage, the wire or the lamp gets hotter and hotter. You can't see that on the graph, but this is the explanation. The wire is getting hotter and hotter, and as it gets hotter and hotter, it gets more and more difficult for the current to get through. So you see, you get less of an increase in the current as you increase the voltage, and this is due to the particles vibrating more in the wire, and if the particles are vibrating more, it makes it more difficult for the electrons to get through. This is the classic shape of a diode. It's showing basically that if you try to push a current through a diode in one direction, it will not go through. Notice the minus V. As you go minus V, increase the minus V, you don't get any increase in current. In fact, you get no current at all, showing it's not allowing current in that direction. But if you push it in the different direction, it actually allows current to go through it. If you notice, there's a bit of a delay, because in order to get a diode work in the first place, you've got to give it a bit of energy, and so maybe 1 or 2 volts will trigger it, then at that point it will shoot up and obey Ohm's law. But whenever you see that shape, that is the characteristic shape of a diode. So if you sketch that, you could say, you know, on a memory card, you'd say, what does this graph show? You'd show it shows a diode. What does a diode do? It allows electricity to go in one direction only. This is basically showing us that you can interpret the Ohm's law diagrams like this. If we look at the purple line, that purple line there is showing us as we increase the voltage a lot, the current is hardly increasing at all. The purple line, that tells us that's got high resistance, that the electricity finds it very difficult to go through that wire. The red line is showing you a conductor with low resistance. In other words, all I had to do was give it a small amount of voltage, a small amount of energy, and I ended up with a big current. So it's dead easy for the electricity to go through. You can see the scribblings out that I've done there shows you that even I'll get caught out by this. So you've got to think about these carefully. The gradient, the steepness of the line, is telling you how much resistance there is. Right, the next two are basically showing two of the electrical components. One's an LDR, or light dependent resistor, and these behave rather strangely. And this time we're not looking at voltage and current. If you look along the horizontal axis, that is light level, and it shows us as you increase the light level, the resistance decreases. Okay, what actually happens is the light, when it hits the LDR, actually causes electrons to be knocked off a substance, and it makes it easier for other electrons to get through, for the electrons to flow through it. So basically, all you need to know is as light levels increases, the resistance decreases, and that is the signature of an LDR. The next one is exactly the same shape, but it's a thermistor. And because it's a thermistor, it's showing that as you increase the temperature, the resistance drops. And this is totally different to filament lamp. With a filament lamp, as you increase the temperature, the resistance increases. But with the thermistor, as you increase the temperature, the resistance drops. And there is a diagram of what the thermistor should look like. And those are the 6 graphs that you may face in an exam.